This tutorial is going to be in Godot, but a lot of the concepts here should be able to work in other game engines. Also, the tilemap used here is free for download, and the finished product is going to be on GitHub. Both links will be in the description. This is just part 1. It's going to show you how to create a program that generates the points for the graph for the pathfinding system. With all that out of the way, let's get into it. Okay, so right off the bat, you're going to want to set up your own tilemap. You can make it look however you want. If you don't know how to do that, there is a link in the iCode and the description to a video of how to do auto tilemaps in Godot. I'm not going to be showing that here. So the first thing you're going to do is create a 2D node and rename it Pathfinder. And then go ahead and just attach a script to it. And then we're not going to need anything in here except the ready function for now. Okay. And then we're going to need a variable for the tilemap and for the graph. So the tilemap is going to be this tilemap right here, the one we set in our scene. And then the graph is going to be a new variable we declare in here. That is going to be a star 2D So after creating a new graph, we're going to go ahead and find the tilemap. So the way I'm going to do this is I'm going to find the parent node, and then go down from the parent node, which is the master, down to the tilemap. And that should allow us to grab the tilemap for whatever we need it for. In this case, it's going to be what we're going to be using to build up the graph. And then we're going to go ahead and set a function right here. This is going to set all the points for our graph. And to do that, we're going to go ahead and just loop all of the cells that we're using in the tilemap. And this is basically going to be all of the cells that have an object in it. We're going to go ahead and loop through all of the cells so that we could find out which cells we want to use on the map. The map is going to look something like this. So as you can see here, it's only the points that the character could walk on and the endpoints. It's pointless to contain the midpoints because we could include that in a in between of the endpoints. And then also, if you see drop downs, we're going to have points there too. And the first thing we're going to check for is to see if any cell is above it, because we only want the top layer. Equals vector 2. This is your x. It's going to be the current cell's x, and then your y minus 1, which in this case is going to be up 1. So if the above cell is in the cells that we're using, actually if it's not in, then we essentially want to place a point right here. So let's create a new scene. I'm just going to call it face. It's going to be the Godot face. It's going to basically be a sprite that's just showing us where that point is, so we know it lines up right. And I find for this one, with a 16 by 16 a scale of just 0.1, so a tenth the size, should be good. So if we go into master and drag in the face, that's what we want our point to look like. So we need to set a prefab, or a preload. of that scene. And then down here where we're going to try to create the face, in the above cell, we're going to create an instance of that preload. So var face equals face dot instance. And then you want to set the position, which is going to be the above cell, and then set it as a child of something. In this case, we'll just put it as a child of Pathfinder. And then we're actually going to add a cell size, which is going to be 16 divided by 2 to both the X and Y, which is going to help center it, the face, in that position. So vector 2 and then we also need initialize cell size. Up here, that's just var cell size is going to be your size of each cell. In this case, it is 16. Make sure the tile map you get is the actual tile map, not a null. Okay, so if we run that, it is doing nothing. We forgot to set it as a child. So if you were to go add child face. Now when I first did this, it actually didn't work, and it was creating a conflict. The way I went ahead and fixed that was adding a call deferred add child test face. And so if the add child isn't working, adding too much child and it starts creating a conflict, you could do call deferred. It's a little bit slower, but it won't error out. So I'm going to do add child. So now that we got it in each of the positions, or each of the places that the character could walk, we want to get rid of all the ones that aren't edge pieces, because those are just going to slow down the pathfinding process and they're kind of pointless to have. And to check if it's an edge piece, we basically want to see on this tile map if the cell to the right is open or the cell to the left is open. Then it's an edge piece. Or even if there's a wall to the above right or a wall to the above left, then it's open. And actually, I'm going to need to check that later on, not just here. So I'm going to create something called a CellType, a function that I'm going to pass the position, and it's going to tell me what the CellType is. So basically what I'm going to do here is, the first thing, I'm going to check, see if there's a cell above the current cell. If there is, then we don't need this, so I'm just going to pass back null. If there's not, then it's going to resume. It's going to create a variable result, which is going to be a tuple or a vector 2D. There's going to be two values. the first value is the left status, the right value is the right status. So if we were to go in here, that would be, if we were talking about this cell right here, the left value is going to be a 1 because there's a wall. The right value is going to be a -1 because there's a drop. And then if it was just flat, it's going to be 0. The reason I only need 2 instead of 4 is if I had something like this, I would treat that as if it was a wall, not a drop, because the character wouldn't be able to move through there anyways. So that's what this is doing. It's checking if the position to the left and to the up is in cells, then there's a wall. So if the position just to the left of the current cell is not in cells, then it's going to be a drop. So it's going to be 1 if it's a wall, -1 if it's a drop, and it's going to stay 0 if it's neither. So I'm going to go ahead and code this on the right side too. Okay, so this one's basically the exact same, except it's going to change the second position of results, and it's going to +1, so it's looking to the right instead of the left. Okay, so that should tell us whether it's an edge piece. So instead of doing above here, we're going to go ahead and do type equals CellType of cell. Now if type and, so basically if it's not returning a null and type is not equal to 0, 0, so that's going to say if it found that it was a wall, a drop on either side, and it found that it wasn't returning null, then we're going to create the face above. And actually, I'm going to end up moving all of this into a different function that is going to create the points. That way I could just call create point. I don't have to retype that exact thing. So right down here, I'm going to create a function, create point. And then I'm just going to pass the cell, which is the current position inside the tileMap. So I'm going to initialize the above, the cell right above, which is where the point's going to be, just like it was before. And position is going to be the tileMap dot map to world that we used before. Above plus vector 2, cell size divided by 2, cell size divided by 2. This is going to center it. I forgot to call create point. Okay, so it's creating all the points in the corners. Now we need to create points that are directly drop downs. So if they were to go here, the guy could jump down, or here the guy could jump down. So we want to create points that are directly drop downs, not just corners. So basically, if we're on a corner piece, we want to check. So if the type and the type isn't just flat ground, we want to check if either the left side or the right side is going to be a -1. We want to cast array directly downwards from that point, and then see what tileMap or see what cell we hit, and create a point right above that centered. So because we have the create point, we should just call that after finding the map. So if type of 0. So if this is on the left side equals -1, then we want to grab the position of that cell so we could cast array directly down from that position. So variable position tileMap, map to world, vector2, cell of 0 plus 1, so that's going to be to the left. No, that's wrong. -1. And then cell of 1. So the same height to the left. For position 2, vector 2, US 0, US 1 plus 1000. So that's going to cast array downwards 1000 of the current position. And then by results equals space. Right here we need to actually initialize a space state, which is going to allow us to cast arrays from. Okay, so this will allow us to cast arrays if you were to do space state dot intersect array and you would do position 2. So that's going to cast array from this position to this position, and the result is going to be what it hits. So if it hits anything, then we want to create a point, and then we're going to cast in the cell that we're going to pass in the cell that we found, which is going to be tileMap world to map. So this is going to map from the world's position back to the tilemap's position. Result dot position. Forgot an S. Actually, no, let's just get rid of that S. Okay, and if you're confused what I mean, world to map, we map to world. The world coordinates, if I were to take a face, the world coordinates are going to be these. If I were to go to tilemap, the tilemap coordinates are going to be a lot different. Basically, this might be 0, 0, 0, 1, 0, 2. So each one's increasing by 1. So that's why I have to map to world and world to map. Okay, so if this works, it should create all drops on left side should create a drop, and they aren't. So let's see. I actually forgot to add a collider to my tilemap. I will be back. Just in case anyone's curious, the way to add collisions to tilemap, you just click on a cell, click here, double click, click here. You don't even need double click, I just double click because it's faster. Okay, now that the collisions are added, we check, and it's added points right there, point right there, point right there, point right there. Okay, so now let's go ahead and do that to the right side too. Okay, so when checking that, it works just the same. And then this almost immediately presents us with another issue. And that is this guy right here drops down and creates one right here. And this one drops down and creates one right here. So there's probably actually 2 faces right here and 3 faces right here, because this one's created one because it's a corner, this creates one, this creates one. So right now, I'm not actually going to present the solution to that, because it's easier to do with the graph aster, which we didn't create yet. So I'm going to start placing points in the graph aster. So to add points in the graph aster, it's actually pretty simple. All you need to do is graph, just call the name that we set it to, add point, graph.getAvailablePoint ID. This will get the next available point ID. That way you don't need to calculate it out or anything. And then I'm just going to set it to position. Okay, so this should actually create points all in the same points that we have here. Now after getting the position, but before creating anything else, we want to actually check and see if the point is trying to create a duplicate point. So we're going to get the closest point to the current point we're trying to create. Then we're going to see what that point's position is. So this is going to give us an ID, like 0, 1, 2, 3. We're going to do graph.getPoint position at this, so it's going to give us that position. If that position is directly equal to the position we're trying to create, then that means there's already a point there. And we could just return. We don't need to create a point because there's already a point there. So if this point right here has 2 points on it, this one might connect to one of the points but not the other, and then the other point could connect to this one. So that'll say that this point can't go to this point. So it's actually important to make sure you don't have points that are in the exact same spot. And just a verification that that actually worked, we're going to print, after creating all those, we're going to count the number of points in there. So when I get rid of it, it prints those 53 points, which that looks like a lot less than 53. But when I add it back, it's going to print that there's 44. So it was creating duplicates, now it's not. Thanks for watching. I'm currently working on part 2, so I'm going to get that posted as soon as possible.